Hi guys, today we are going to look at the problem called squares of a sorted array. This is a problem on LeetCode, which is problem number 977, and it's classified as an easy problem. Now, before attempting this problem, we need to look at three parts of this problem. So first being, we need to understand the problem statement. This step is quite critical as we need to ask the users or the interviewers what they are expecting, what the solution should be, any clarifying questions we have, any discussion on the input values and the output values. This will frame our thought process on the particular problem. So let's have a read of the problem statement. We are given an integer array nums, which is sorted in non-decreasing order, and we need to return an array of the squares of each number sorted in non-decreasing order. Now, if we look at the input, we are given an array or a list -4, -1, 0, 3, and 10. We are supposed to return a list or an array which has 0 corresponding to 0 square, 1 corresponding to -1 square, 9 corresponding to 3 square, 16 corresponding to -4 square, and 100 corresponding to 10 square. Bear in mind that the return is also in sorted order. It's sorted in ascending order or non-decreasing order. The same thing with this particular array where we have -7, -3, 2, 3, and 11. And the output is going to be 4, 9, 9. So 2 square is 4, -3 and 3 square is 9, -7 square is 49, 11 square is 121. Now that we know the input and the output, we can go over the constraints of the problem. So the constraints are that the length of this particular array ranges from 1 to 10,000. So since this starts from 1, we don't need to take care of the case where there is an empty array or the array doesn't have any elements. The elements of the array themselves range from -10,000 to +10,000. Now, after this, we also need to look at how we are going to frame our thought process. Since we have the input, we have the output, and the constraints in mind. So we need to write this down in a pen and paper or notepad or some kind of whiteboard just to see what kind of problem it is and how we are going to think about the problem. So I have a whiteboard here in which I'm going to write down the elements of the array. So say for example, I am having this particular array. So this is an array having 5 elements, -6, -3, 2, 1, and 5. Now, the first thing that comes to mind is, can't I do some kind of brute force where I simply scan through the array from left to right? So I'll calculate the absolute value of each number, sort those numbers, and then square them. So we can find out the absolute value, sort those numbers, and then square those numbers. So this seems like a good solution where we get the result. So we need to think about the time and the space complexity that's involved for each of these three steps. So for finding the absolute value, the time complexity is going to be O of n, as we're going to scan every element. Worst case, all elements would be negative. We would need to find the absolute value or removing the sign of the number. And then every element goes through that process and we get all the elements with a positive number. We need to sort the particular list. Depending on the size of the list, it's going to take n log n time. Languages like Python and Java typically use either timsort or quicksort to sort the array, which typically takes n log n time. And squaring of the array would be again O of n because every element would need to be squared. Now, if we add up these, the dominant term would be the n log n. And if this particular array would to scale to millions or billions of integers, then this would be a dominant term. Now, if the interviewer asks, okay, can we do something better or can you find an optimized solution? Then we definitely can. So what we can do is that, again, given this particular list or array, and if I write this down again, can I try to do this in O of n times? We can think of a way to do it with the left and right pointer. So what we can do is we can initialize an empty list first, which is going to hold the results, and we can declare a left pointer which starts from here and a right pointer starts from here, and have the left and the right pointer meet at some point. Now we can square the numbers along the way and compare them. After the comparison operation is done, we can make entries in this particular list and we can get our result. So once again, we're going to start from the left side and the right side, go this way and have both these pointers meet at a point. Along the way, we are going to compare the squares of both these numbers and make entries into this particular list. So for convenience sake, I'm going to put the indices of each of these particular numbers: 0, 1, 2, 3, 4. Starting from this location and this location, we have the square of -6 being 36. We have the square of 5 being 25. Now, if we compare both of these, 36 is definitely higher or greater than 25. So we put 36 out here. Since we put 36, we increment the L pointer and put it right out here. We again square -3 and get 9. And we compare 25 and 9. 25 is definitely greater than 9. So we put 25 out here and decrement the right pointer. So the right pointer goes out here. Now we compare the square of this and the square of this. -3 square is 9. 1 square is 1. Comparing both these, 9 is greater than 1. So we put 9 out here and increment the left pointer. So left pointer goes out here. 2 square is 4. We compare 4 and 1. 4 is greater. We put 4 out here. Increment the left pointer. Left pointer goes out here. At this point, the left and the right pointer are the same. Since they are the same, we just square 1, which is 1 itself. Put the entry out here. Now we have an array or a list which has the elements in decreasing order. So all we need to do is simply reverse this. So if we simply reverse this particular list, we end up with 1, 4, 9, 25, 36, and we can return this. Now, if we go through what we have done, we are simply scanning the elements from the left, scanning the elements from the right at the same time in the same loop. So this is going to take time O of n. So if we write down the time complexity out here, so that is going to be O of n. We have to declare and initialize a list to hold our results. So our space complexity would also be O of n. Now this is a definite performance improvement compared to what we had earlier, where we are doing an absolute then sorting and then squaring, because this took time O n log n, whereas this is only going to take time O of n. Now let's start coding this problem solution up in our LeetCode notepad. So here is the LeetCode problem. Initially, what I'll be doing is I'll be first finding out the length of the array. So I will be declaring a variable called length and finding the length of that particular list. I'm using the language Python. You are free to use whatever language you want, because in all languages the code would be pretty much the same. We then declare a left and right pointer. So left pointer starts with 0 and the right pointer would be the last element, which is length minus 1. So going back here, left pointer out here, right pointer out here. Now, after this is done, I will initialize a list again, which is empty, which is going to hold my results. Then I'm going to start a loop, which is going to compare the values of left and the right pointers. And I'm going to proceed the left pointer this way and the right pointer this way. Now I'm going to take the square of the element at the left pointer. So I'm going to do square of this number, and I'm going to do a square of the right number. Now I have both these numbers with me. So remember, this was 36 and 25. Now we need to do a comparison operation between them. So if the left square is less than the right square, what we do is we're going to add that particular element to the final list out here. So I'm going to say final dot append right square, since right is greater than the left square, and I'm going to decrease the right pointer. Else, if my left square is greater than or equal to the right square, I'm going to append the left square and increase the left pointer. So if 36 greater than 25, add 36, and then when we're comparing 25 and 9, 25 is greater than 9, so put 25. So then increase the left pointer and decrease the right pointer. Now, after this is done, our final list or final array is going to have all the elements sorted in decreasing order, as we saw here at this particular step. We just need to reverse this and return the results. So in Python, reverse would be a simple colon colon minus 1. And I'm going to run this with one particular test case. So if I run this out here, there is an issue where the left square was referenced before assignment. So I'm going to initialize that particular variable. Okay, so it seems like I just had to use the left and the right out here instead of left square and right square. And once I run this, I get the results in the format that we want. And if you see the runtime, it took 27 milliseconds. Now we can try some other test cases. So how about we try the test case that we discussed on the whiteboard? So if I say -6, -3, 2, 1, 5, and we can run the code. Okay, so it's saying that the nums must be non-decreasing. So let's put it in that way. So we can just replace it and make it 115. And we have our output out here, 149, 25, and 36. Now we can try another test case that is mentioned out here. And here we can run the code and we get the output. Now we can run this code for multiple test cases. So let's see what happens. So now we see that our solution has been accepted. And once again, the time complexity is O of n because we only use a while loop. And the space complexity is O of n because we've initialized the final variable. Thank you and have a nice day.